All right, so previously we mentioned that when we have compounded m number of times, okay, when we are compounding annually, then m equals to 1. When we are compounding semi-annually, m equals to 2. And quarterly, m equals to 4. Monthly, m equals to 12. Weekly, m equals to 52. And daily, m equals to 365. But what will happen if m becomes very large? Maybe we are compounding hourly, or secondly, or minutely. So that is what brings us now to what we call the continuous interest. Continuous interest. So in this one, we are talking about when we are compounding continuously. Continuously, if m is now large. So compounding continuously means we are compounding non-stop. And it's used when m becomes very large. When m becomes very large. So compounding continuously, in compounding continuously, you recall our formula. You recall our formula of S equals to P1 plus R over M, then M multiplied by N. You remember that formula. Okay, so when we are compounding continuously, we exchange or we replace this part of that formula with e raised to power r, with e raised to power r. So the formula for compounding continuously becomes this. The formula for compounding continuously becomes this. Okay, now we can call this equation 4. So whenever we are asked to solve a problem that involves compounding continuously, then you replace this with e raised to power r, then you use this formula. That is the formula to use when we are compounding continuously. Okay, so now record the formula again. This is our equation 1 for simple interest. This is our equation 2. This is our equation 2b. This is our equation 4. Please take note of the formula. Equation 3 is this one we have here. The one we call equation 3 is this one we have here. So that is our equation 3. Okay, please take note of this formula and ensure that you are able to know how to use them. Okay. Now, sometimes we want to compare interest rates. We cannot compare two interest rates without bringing them to the same rate first. So that means in order to compare two interest rates, we must bring them to effective rate. Both of them to effective rate. Okay, so we have this formula that helps us to convert from one interest rate to another one. So if you are given a nominal one, then you can convert it to effective rate. So I can call this one equation 5. If you are given continuous one, then you can still convert it also to effective rate. I call that equation 6. If you are given a nominal one, you can convert it to continuous rate. I call that equation 7. So please take note of the formula. I mentioned that in this session of Mathematics of Finance, you have so many formulas to use, and you must make sure that you know how to use them. You must know them and know how to use them. Okay? Now, when you are comparing two interest rates, two things are very important to know. Number one, if you are investing money, then you choose the highest effective rate. If you are investing money, choose the highest effective rate. But if you are making debt or you are to pay debt, then you choose the lowest effective rate. Then you choose the lowest effective rate. You choose the lowest effective rate. Okay. Now, for example, if an investor, don't forget an investor is investing money. If an investor has a choice of investing money of 6% compounded daily and 1/8 compounded quarterly, which is the best choice? So we cannot know the best choice without first change them into effective rate first. You must first change them to effective rate before you can know the best one. And since we are investing money, we must choose the highest effective rate. So the first one, we change this 6% to effective rate using this formula, and then you get that it is 6.18. In the second one, we change this to effective rate, and then you get 6.27. So because we are investing money, we have to choose the highest one. Because we are investing money, we have to choose the highest one. Okay, please take note of the formula and ensure that you understand. Okay.